All right, everybody. Here we go. 8.3. This is the final notes of the whole book. So, yep. Here we go. Outline the role of urban air pollution. Start off with that one first. So we're going to be talking about the air quality in urban areas and also how it affects areas outside the urban community. Before I go any further, let me put this on a focus. That way I don't get embarrassing text messages that come up. Let's go for 1 hour. All right, bang. All right. Outline the role of clouds in regulating global average temperature. So, this question, I know you're thinking, how does it directly really apply to urban communities? And the answer is it lightly does. Not in a strong sense, but, it is there. So, clouds play a negative feedback role in just regulating the temperature. So, they trap heat, but they also block sunlight coming on in. So they have a high albedo because clouds will reflect sunlight, pow. And obviously reflect sunlight, that's going to keep the earth cooler. Now it does tend to do this more with the low, thick clouds, like, with reflecting sunlight, and it keeps the world cooler. If you've got the high, thin ones, what it does is it tends to trap heat more, and then it makes the earth warmer. So right there's a bunch of things you can talk about with this. Also too, how clouds are formed. They're formed from evaporation. So as the heat starts increasing, during a warm summer day, we start having a lot more evaporation of water, and that's what forms clouds. So you can talk about how temperature increases, evaporation increases the amount of clouds. So, yep. All right, got that covered. Onwards to urban air pollution, right over here. So air pollution is contamination of the indoor or outdoor environment by chemical, physical, or biological agents that modify the natural characteristics of the atmosphere. I bet you wish you had the opportunity to define that on your own, because if you were going to write that down, I would probably write it in words that were a lot less. But yeah, it is what it is. So particulate matter, PM is a good thing to remember, is made up of very small particles of solids or liquids in the air. You cannot see them. So we talk about later on ppm, parts per million. All right. So particulate matter, PM, is generally how we're going to measure the weather. So air pollution is caused by solid and liquid particles and gases that are suspended in the air. These come from natural and anthropogenic human-caused sources. Natural sources are volcanoes, dust storms, wildfires, pollen, mold spores, things like that. They're just going to occur naturally. Now, granted, you can limit them, which is cool, but they are going to occur even if humans weren't on this planet. So, anthropogenic sources are vehicle exhaust, industry, forest fires, indoor spray cleaning products. Also candles, too. I used to be a candle man. This is back in the day in my 20s. Actually, I still have candles around this place. I've decided not to really burn them. I've got a smart thermostat at the home, and it regulates temperature, saves me money, all that sort of stuff. But it also tells me indoor air quality, and when you burn a candle, oh my God, it instantly turns the air quality to crap. So no longer, I know candlelight for me, it's like a little bit of pyro, it's very soothing, it's calming, but it's also very bad for your lungs. So yeah. All right. So cleaning products. Primary pollutants down here are these emitted directly from a process, mostly from combustion of fossil fuels. So examples are carbon monoxide and complete combustion of fossil fuels. They're doing quite a bit better with these. I will give the auto industry this, because the whole idea of how do you get more power while using less fuel is that you burn and use the fuel completely. So they're doing a better job of this. Also, too, I've seen this not just with cars, but also with even wood-burning stoves. I got shown a wood-burning stove once by this one nuclear engineer, actually. He was describing about how the purple flames are good because they burn at a higher temperature, and therefore you're burning the fuel completely and putting less out in the atmosphere. So, yeah, less emissions, more heat, according to him. All right. Carbon dioxide. Oh, by the way, carbon monoxide is the one you can't really see. It's a silent killer. That's why you've got carbon monoxide detectors in your home, because no one wants to die without any warning in their house. Carbon dioxide is the stuff, CO2, that gets put out from cars that you do kind of like see, I imagine, more than carbon monoxide. That's the greenhouse gas right there. Unburned hydrocarbons as well, nitrous oxides, nitrogen dioxide, and nitric oxide as well. Sulfuric dioxide, coal from high sulfur content. It's a big one. Particulate matter, PM. Told you we'd get back to it. Smart particles that are inhaled that you generally do not want to. Mercury from coal-fired power stations. That one I did not know about until I was reading the book. So mercury, remember, is a toxic metal. Having that out in the atmosphere, ooh, not a good spot for it. So we like mercury where we found it. Not really looking to use much of it. Sulfur from coal with high sulfur content. Yep. So up there with sulfur dioxide as well. So those are all primary pollutants. Secondary pollutants are formed when the primary pollutants undergo reactions in the atmosphere. So basically, those primary pollutants combine with something else to make a secondary one, often in the presence of sunlight. So like sunlight does damage quite a bit. You ever have something where you left out in the sun and then like the color changed on it? So sun does have an effect on different things, on reactions. Examples: tropospheric ozone from hydrocarbons and nitrous oxide in the sunlight. So basically, the tropospheric ozone forms with those hydrocarbons, which are the primary pollutants, and the nitrous oxide, and how they react in sunlight. So keep in mind that's going to be more during the day than at night, because obviously sunlight. Particulates from gaseous primary pollutants. Peroxidal, let me see if I can pronounce that one better. Peroxidicyl nitrate, PAN, a stable oxidant. Nitrogen dioxide from nitrogen oxides plus another oxygen added onto it will form your nitrogen dioxide. Sulfuric acid and nitric acid, these from sulfur dioxide, nitrogen oxides plus water equal acid deposition. So, yep, acid rain, baby, right there. All that good stuff. So, facts about air pollution. Let me bring this one down here. Yeah, to right there. Leading cause of death is heart disease, stroke, infections, lung cancer, COPD. So air pollution does quite a bit as far as like respiratory issues. So respiratory is your lungs. That's also can involve your heart. If you have conditions where you're already weak for that, that's going to set you up even more. Asthmatic, if you're a smoker and you have COPD and you're living in an area where there's like factories and stuff, yeah, it's probably not going to do too good for you. My mother-in-law, growing up in God, she's 82 now, and anyway. So 82 years ago, let's put her in the 1940s. Yeah. Growing up 1940s Puerto Rico, they didn't really have inhalers for someone with asthma. So the, treatment was move out of the city, move off into the country, get some fresh air. So, yep. All right. Contribute to 11.65% of all deaths in 2019 globally. Now that COVID happened the year after that might have affected that number a little bit more. That'd be an interesting IA. Greater in low-income countries, solid fuel use, and medium-income countries, industrialization. So remember, poor people always get screwed. No way about it. So lower-income countries and also as middle-income, where they have a lot more factories, industry, they put a lot more off into the air. Here in the United States, we don't have as much of manufacturing. We're a high-income country. And so we do a lot more with services. So we get a lot of clean air. Don't get me wrong. We still contribute to that air pollution because where is stuff made? We just buy it from people that do the polluting for us. So, so don't hang your head too high on that one. 2.5 billion people are exposed to air pollution levels 7 times higher than the World Health Organization guidelines. A lot of that's coming from where stuff is manufactured. Start looking at Asia. So, over 90% of air pollution in low-income countries comes from old, poorly maintained vehicles. Yep. United States, we have money for catalytic converters, and we also regulate exhaust. In other countries, they do not have that, and they are not checking to see if you have a catalytic converter on your car, or even the pollutants that are coming out of it. So that might actually be something worth fixing. The only problem is we're going to have more cars in those LICs as the years go by. It's just the way people go. People always do what's best for them. So I'm not sure if there's a way around that. Making cars smaller, making their engines smaller, forcing regulation of emissions, having it where it's just jumping a stage and just going straight to EV vehicles, something along those lines. The advantage of EV vehicles is they don't require as much maintenance from what I've seen. TOK, are intuition, evidence, reasoning, consensus, and authority all equally convincing methods of justifiably accepting air pollution facts? Yep. So what kind of hits for you? Some of those hit a little bit more for me. Yeah, there's one that definitely hits more for me. But yeah, that's up to you. There's no right or wrong answer for it. Just back it up. Typical IB stuff. Other causes of air pollution. Wildfires. These ones are affecting us in the Northeast United States. Mostly caused by human activity, burning stubble, cigarettes, campfires, arson, but can be natural as well. From the ones that I've heard that we're not experiencing as bad right now as we did a few years ago. What happens is the trees off in Canada, which really shouldn't be burning as much as they are. But just guess what? Global warming, the temperature stays warmer during the winter time, so the ground doesn't really freeze as much, and the fire smolders underground, and then come springtime, it just roars back up. It's called a ghost fire. Kind of interesting. Anyway, so trees go up in flames up in Canada. That smoke then gets spread by the wind down to us down in the northeast part of the United States. And it's just hazy and nasty and really does bad stuff for our air quality. Really shouldn't have the fires as much as they are, but like I said, climate change, just a warmer environment, really doesn't put out the fires when they happen. A lot of those fires are happening naturally as well. I've heard lightning strikes were the major cause of them. So, all right. Produce PMs and other toxic chemicals, increase heat, thermal pollution, risk of more fires. Yeah, so doesn't take a rocket scientist to figure out, a forest fire can then propagate and cause an even bigger forest fires or more forest fires, and stuff gets blown in the wind. Wind is the thing that a lot of those firefighters, from what I've heard, really don't want to see, because what it can do is it can take that fire and just blow it and expand it and put a superhighway onto it. So obviously particulate matter, it's going to increase that along with toxic chemicals, and fire produces heat. So pretty nasty. Chemical industries release chemical organic compounds. Microbial decay produces methane. They had a problem with PCBs in a river west of us, way off in the Berkshires. But basically, the company that made a lot of those transformers for the electrical, they're the big trash cans you see like on top of metal trash cans you see on top of on top of electrical poles. The company that was making those would just kind of dump a lot of their chemicals off into the river, and they're forever chemicals. So yeah, kind of polluted the river forever. Nasty. All right. Construction and demolition. Produce particulates from machinery using fossil fuels. Also cause noise visual pollution as well. Yeah, that can't be understated. I'd forgotten. A lot of times we look at big heavy machinery, and yeah, we know that it's like destroying the land and stuff, and it doesn't run on unicorn tears. It runs off fossil fuels. But there's also the noise level and visual pollution as well with it. I've got a buddy. I just saw his kids. I hadn't seen my buddy and his kids in a while. And one of the kids was talking about how their go-kart, they can't run it at night because the neighbors don't like the lights like blaring into their house. And yeah, they live on like 60 acres, so they go rolling around in those go-karts. But yeah, so visual pollution. Also, too, no one as your neighbors probably, they're settling down at night, 8 o'clock at night, they don't want to be hearing a two-stroke engine. So, yeah. Construction demolition, yep. Indoor air pollution. Inefficient fuels in poorly ventilated areas. Yeah. So, keywords there. Poorly ventilated areas, not enough airflow. That's one of the issues we have a little bit with better insulation. Not as much air comes into your house or into your building. The air is not fresh. In Germany, Austria, I was over there for a little bit in the hotel, and even though it's the middle of winter, they would open up the windows, when they're cleaning your room, and you're like, why would you do that? It's like it's freezing air out there. No, keep the warmth inside. But their mentality was just to get fresh air in once a day. So burning inefficient fuels. So yeah, when you're burning like fuel, imagine you've got a gas stove and it's burning the fuel inefficiently. That's going to put out carbon monoxide. Interesting enough, my brother his wife is very she can smell something a mile away, and she's very particular and has reactions to it. So they have a gas burning stove, or had one, because in 5 days they're getting it replaced by a induction stove. So basically, the gas stove, she could smell it, and it was giving her allergic reactions with breathing and stuff. I don't know if it's carbon monoxide or what, but yep. As a result, it's not worth the marital fight to my brother, and he's just like, fine, we'll get rid of the gas stove if I love it, and we're going to get an induction stove. So, yep. Induction is purely electrical, by the way. Works off magnets for heating. Indoor air pollution and inefficient fuels. All right. Let's see where we're at here. Yep, 100 times more fine particles than safe limits. Yep. Poor stoves, smoke from tobacco. Yeah, it's kind of nasty, but people that smoke inside, that will ruin your real estate value faster than anything. By the way, not just cigarettes, but I wouldn't even, like, the people that vape inside think like, oh, there's nothing to it. I don't know, dude. I mean, like, anything that's going to put out particulates off into the air, I don't really feel like is a good thing. VOCs from carpets, paints, adhesives, cleaning products. World Health Organization, WHO, facts. 1/3 of global population cooks with unsafe fuels. Yep, does it. In 2020, 3.2 million deaths from household air pollution. So, yep, there you go. And that was during the COVID year, by the way. So, yeah. 650 children under 5 die per day due to it. So, yeah, we take things for granted, but children under 5 do not have the immune system and the resilience that older people do. Combined ambient plus household air pollution, 6.7 million deaths per year. So, all right, those are just some statistics and some numbers for you. Particulate matter, PM. Microscopic solid or liquid particles, more concentrated in urban industrial areas. Why? Because we have more people around. There's more of things. We're off in the country, it gets spread out a little bit more. So, PM's less than 10 micrometers. I don't know what that sign is. Let's check it up. All right. Meaning. Micrometer. Haha! I was right. Good. All right. Less than 10 micrometers, equal or to less than 10 micrometers. Particulate matter, 2.5, less than 2.5. More harmful as they enter lungs and the bloodstream. All right. So, yeah, the smaller they are, the more harmful they are. Yep. Effects. Toxic metals, cadmium, lead, nerve, kidney damage. Ooh, kidneys, going for dialysis. That's where you have to go and have your Blood basically processed every, I think it's 3 days. So it makes vacations rather difficult and traveling. All right, allergic reactions, sneezing, running eyes. Think of allergies from Hades, really bad allergies. Bacteria, fungi in particulate matter causes infections. Yep, can do that. Asbestos fibers. Oh, all right, from old buildings. Careful because asbestos can be in a lot of houses that you're going to buy. And asbestos remediation is not cheap. That means the remediation is where they take it out. Why? Because it basically puts out these little fine fibers, and as you inhale them, they are stuck in your lungs forever. And yeah, as you can imagine, you only have so much lung tissue. So as that gets filled up, your ability to breathe is not as good as it should be, and you come down with a bad case of dead. So irritates mucous membranes, increases stress, asthma. So yeah, keep the air good. TOK, to what degree do we have a responsibility to share knowledge about particulate matter? So yeah, I should bring this up to my father. My father smokes, and just every time he comes in the house, you can smell it a mile away. So, yep. Let's go with air pollution managerial strategies. So, management strategies. Reduced by altering human activity producing pollutants. Yeah, the idea of simply if you do smoke, like people that smoke, take it outside. And after you're done with a cigarette, stay out there for like 30 seconds, a minute, let it blow out, and then go inside maybe. All right. Also, just making sure you're heating with the fuel or cooking with fuels that or energy that really doesn't increase your particulate matter inside your house. Are controlling pollutants released via legislation and technology. Technology is really pretty cool about the way it's going with just improving air quality. This house right here, where it's gotten to the point where things are starting to break, and you got to replace them. So what do we replaced? Well, we replaced. We have a furnace here that goes on when it hits like 30 degrees, and obviously the furnace burns on, can burn on different things, but it burns on propane gas because it's economical. And that you have to worry about with like indoor quality and fumes and air quality. But we have a heat exchanger that heats the house all the way down to 30 degrees outside. So, and that does not contribute at all because you're not producing heat, you're just exchanging it basically. So that's going to keep your PMs low. Also, too, we have an induction stove so we don't burn fuel. Don't get me wrong, it doesn't run on unicorn tears. It's still producing greenhouse gases. It's just doing it at a facility like where they're burning propane down the road or whatever at at an electrical plant. So, all right. Examples: improve public transportation, use renewable fuels, reduce cars, less congestion. Yeah, so car-free zones would do quite a bit for that. Also, electric vehicles as well, using biofuels, stuff like that. Improve cycling infrastructure. Love these. I bike to work when I can. And the bike lanes really improve real estate value. And I'm a lot happier when I get to work, too. I should bike to work on the days where I'm grading test. So, plant trees, vegetation, urban areas. Yep. Why? Because trees and plants, they don't build off of they do take nutrients from the soil, but a lot of where they get their building material is from the air. They're like, yeah, and then that's when they get big. They take carbon out of the atmosphere and other pollutants as well. Absorb pollutants, improve aesthetics, produce oxygen, improve real estate values as well. Yep, catalytic converters in all vehicles, make that global. So, get a way to check those too. Remove 98% of the pollutants, convert to less toxic substances. So that would be a great start. Pedestrianized town centers. Yeah. Why? Because when you got cars just stuck in traffic, they're just putting out emissions. And the air doesn't really flow very well in town centers. So those emissions just sit there and kind of rot there. So promote walking, all that good stuff. Yep. Actually, if you look, one thing so start looking at things different cultures do. In the United States, we're a bunch of fat kids. We drive everywhere. Like we drive to the mailbox, we drive to this place, we drive to that place. Walking like is something that's a lot more common in Europe and Africa, other places as well, Asia. And so the result is in the United States, we have a much bigger problem with obesity than they do over in other countries where they walk quite a bit more. So, acid deposition, acid rain, precipitation with acidic components, sulfuric, nitric acids. Two forms: wet deposition, which is rain, snow, fog, hail. Great, right? All that sort of stuff. Keep in mind, snow does fall under wet deposition. So, dry deposition is where you just have ash or dry particulates, where it just gradually falls to the ground. Obviously, I think wet tends to bring it down quite a bit faster and more, but it also makes it so acid rain, which is one more reason why it's not great to drink stream water. It's better if it filters through the ground a little bit. All right, acidity. Acid releases hydrogen ions, measure using the pH scale, 0 to 14. Remember, 7 is neutral. So anything less than 7 is acidic. And the closer it gets to 0, the more acidic it is. Now, as it gets further up towards 14, it becomes basic. All right. So 8 would be basic. 9's basic, 14's basic. So normal rain is pH of about 5.6. Slightly acidic due to carbon dioxide. Even if you didn't have humans out in the atmosphere on this world, it would still be slightly acidic because you're going to have volcanoes and wildfires and stuff like that. So you're always going to have carbon in the atmosphere. So the rain will always be lightly acidic. The problem is with us putting out so much emissions, it's actually taking that pH and it's lower than 5.6. Sometimes it can even get like this, according to the book, is like down to 2, which I don't know how you even survive that. That's more acidic than anything. Yeah. Main acid deposition, pollutants and sources. Primary pollutants are sulfur dioxide, nitrogen dioxide. Sulfur dioxide is the major one, I believe, for acid rain. Secondary pollutants are when that sulfur dioxide reacts and makes sulfuric acid and also nitric acid as well. Carbon dioxide, this forms weak carbonic bonds, so it's not as big for acid rain, I guess, but it's still going to contribute as well. Sources are natural volcanic eruptions, sulfur dioxide, woo, boom, all right. Lightning produces nitric oxides. You're not really going to stop lightning, though. You can't really control it either from what I've seen. The things we can directly control a little bit more are fossil fuels through cars, industry, power stations, heating, things like that. The key reactions are nitric dioxide plus water, H2O, plus oxygen forms nitric acid. All right, sulfur dioxide plus water plus oxygen, those are the H2O and the O2, forms sulfuric acid. The sulfuric acid really contributes to the acid rain again. Carbon dioxide plus water, H2O, forms carbonic acid. So, yep. And these arrows mean that they can go both ways. So it can then break down into water and carbon dioxide as well for carbonic acid. Effects of acid deposition. Direct effects. Acid falling on forests damages trees. So how it damages trees is this. Acid rain falls, and yeah, it can attack the roots and stuff like that, but also attacks the leaves. And remember, we need the leaves for photosynthesis. Without those, trees come down with a bad case of dead, no energy. So acid lowers lake and pond pH. Harms aquatic organisms. Ooh, yeah. Could you imagine living in an acidic atmosphere? Oh my God, no way. It's like trying to live your life at a dysfunctional family reunion. No, thank you. Indirect effects. Acid increases solubility of toxic metals, aluminum. So acid breaks down aluminum and then makes it kind of free, where it then can kind of go off into the soils, into your water. And aluminum is toxic to the body. I know we drink from aluminum cans, but they are lined, and generally what's in the aluminum cans isn't breaking it down. So, yeah, acid causes leaching of nutrients from the soil as well. So, Yeah, so acid just frees up a lot of the soil and makes it so that it washes away with erosion quite a bit more. Effects of acid deposition on coniferous forests, which are the ones we get quite a bit, I think, off in Canada. So leaves and buds show yellowing, loss of chlorophyll, and damage in the form of lesions and thinning of wax cuticles. Ooh, I'm starting to have that a little bit with some plants off in the hydroponic unit at school. That's why I'm saying, ooh, okay. Got to check into them. Starting to get some yellowing of the rosemary. These changes reduce growth, leach nutrients from soil, and allow pathogens and insects to enter. Yeah, pathogens and insects are just like anything. They like easy prey. And guess what? When you got a plant that's looking like it's sick and on its deathbed, that's easy pickings. So, symbiotic root microbes are killed, reducing availability of nutrients and tree growth. So remember how we talked about acid rain, how it attacks roots? That's how. Soil particulate particles lose the ability to hold nutrients, calcium, magnesium, potassium, which are leached out. Those are necessary for building blocks too. Releases toxic aluminum ions that damage root hairs. Yeah, just like aluminum is toxic to us, it is to plants as well. Trees are weakened and may die as a result. So that would actually, I'm not gonna lie to you. Like if I was designing the IB test, that one right there would be a great test question. It might be like describe or evaluate the effects of acid deposition on coniferous forest. So, yep. Toxic effects of acid deposition. Aluminum ions affect fish and aquatic organisms. Yep, you better believe it. Acid precipitation lowers soil pH. And where do you think that happens? Because acid rain comes down, breaks up the aluminum, becomes soluble, enters into rivers or streams. And then you have to worry about fish are sensitive to aluminum. Low levels disrupt saltwater regulation, so osmosis, causing oxygen-salt imbalances and suffocation. So that's with low levels. High levels, what happens, the aluminum basically forms onto the gills and it suffocates them directly. So it's more like having the low levels, like, okay, reduce the oxygen in the room, and like having high levels is basically taking a pillow or cloth and going onto the poor fish where it can't breathe. Okay. So yeah. Other toxic metals also dissolve due to increased acidity. So, yep. So it's not just aluminum, it's other toxic metals as well. It's just aluminum's the easy one to show and pick on. So lichens, they are a major indicator of what's going on. Lichens are in the forest. The symbiosis of algae and fungus are sensitive to gaseous pollutants, so like sulfur dioxide, used as an indicator species of air pollution. So we have lichens quite a bit in the forest, where if we don't have lichens, and the lichens are dying back, especially in high alpine environments like Mount Washington, then that's a pretty good indicator of what you got as far as air pollutants. So only a fewer tolerant species survive in polluted areas. Diversity increases further from pollution. So the more diverse, the more variety of lichens you have without pollution. So yep. Nutrient removal effects on soil fertility. Acid rain reduces soil ability to retain nutrients, calcium, magnesium, and potassium. Nutrients are leached out. So acid rain inhibits nitrogen-fixing bacteria, reduces ability to add nitrate ions to soil. Remember, nitrates are really big. They're the fertilizer that will allow plants to grow. So, yeah, without that, you ain't growing much. All right, let's get to the buildings. Acid rain damages human construction. You want to see? Let's take a look here. Acid rain, Notre Dame Cathedral. Yeah. Problem is Notre Dame just had a fire that was, the fire ravages Notre Dame. Luckily, they just rebuilt it and with a lot of money, and opened it up and all that good stuff. So yeah, but they were doing construction on it and there was a fire, unfortunately. But this is what kind of it originally looked like for one of the gargoyles. I don't think they're called gargoyles, but you get the idea. And that's what happened because of acid rain. All right. It's kind of like me in my youth. Very good, very shapely. Yep. Looked good. Looked menacing. And then now over here I got a pot belly and I'm kind of wrinkled and brown and yuck. So, yeah, different things. So, all right. Acid rain with buildings. Damages human construction. The issue you have is acid rain dissolves marble and limestone. Remember, limestone is made from old shells and sea floor and all that. So acid, when it hits it, it just breaks it down like you would not believe. Dissolves it like sugar in water. Corrodes steel, paints, and other surfaces as well. Limestone buildings and statues, even historical, dissolve due to acid. You bet. So yeah, anything that's made out of limestone, and limestone's generally a pretty good material to build with because it's easy to get, it's easy to cut, we're easy to work with, but easy to deteriorate. Peat bogs. Acid rain reduces methane production by 90% in peat bogs. Okay, so not all bad for acid rain. There's when they give you lemons, make lemonade, and hopefully the acid rain isn't on the acid level of lemonade. Sulfates encourage bacteria that outcompetes methane producing microbes. Oh, okay. This lowers methane greenhouse gas emissions. Oh, sweet. Okay, a little bit of, but generally though, jury's still out. I mean, jury is pretty much against acid rain. Human health. Ooh, dry deposition. Particulate matter 2.5 of sulfates and nitrates enter lungs, causing asthma and bronchitis. So yeah, it can have an effect on humans as well directly. Regional effects of acid deposition. Acid deposition effects are regional, not global. So what we mean by that is this. Look, so pollutants go off into the air. Now the wind blows the air away. Now you have clouds that form, and as clouds form, that rain forms with water and brings it back down. So obviously that's going to be more regional, not local, regional, because it can be local as well. So here in Connecticut, we got a big problem. A lot of our air pollution comes down from New York City. So the wind blows it northeast, and what's north from New York City and what's northeast of New York City? Us in Connecticut. So it's a major issue we have. Really bad analogy, but it's like you farting and then just like in front of a fan. It's not going to stay there. It's going to blow it right over next to you. So then everyone else gets to smell your stench. So, all right. Before pollutants spread far, they fall back as dry, wet deposition within a few thousand kilometers. So yeah, so the acid rain that's falling in Dublin is not from New York City. So yep, yeah. The acid rain we get from Connecticut, oh yeah, that is from New York City. So, yep, wet deposition, dry deposition close to source are your sulfur dioxides, all right, SO3, nitrous oxides. Wet depositions are slightly farther, includes sulfurous, sulfuric, and nitric acid. Still not reaching Dublin if you're from New York City as far as the wet deposition. Example, Scandinavian forest lakes affected by the UK, Poland, Germany emissions. So, yep, that is more regional, still considered, still within the continent. U.S. pollution affects Canadian forest. Yep. Conversely, too, Canadian forest fires affect us down here in the States as well. China industrialization affects Southeast Asia. So yeah, a lot of that if you're looking at Tokyo, so let's see here. Tokyo, bam. Let's see just images if we can get a good street view here. All right. Well, that person's not wearing a mask, but let's see. I mean, the general stereotype that no one's wearing a mask there. Okay. Wow, okay. General stereotype is you see a lot of people in Asia who wear masks, and it's not, they were doing this before COVID, but a lot of it's because of the air quality as well. So, just because of the manufacturing in China, a lot of this particulate matter ends up flying on over to other areas, say like Philippines, say Japan, as well, Korea. So, yep. Impact dependency on geology. Alkaline soils, limestone, chalk, neutralize acids. So yeah, I mean, limestone breaks down, but it also neutralizes the acids, which is really pretty cool. Non-alkaline soils, sensitive, biodiversity loss due to leaching runoff. So yeah. Pollution management strategies for acid deposition. Reducing the impacts of acid deposition, liming lakes to neutralize acidity. So what you do is you add like powdered limestone or like something like baking soda to lakes or rivers. This is a temporary fix because it's like you're addressing the I'm sorry, I'm drawing a brain blank right now. You're addressing the symptom, not the problem. So use energy This raises the pH but does not fix the root cause. So that's the problem. And so it's very expensive without a long-term solution. Let's see. Reducing emissions. Reduce combustion of fossil fuels. Use energy-efficient cars, electric vehicles. Switch to renewable energy. Use bike lanes too. Use biofuels, nuclear energy. A lot of us are against nuclear energy, but keep an open mind. I use the word never and forever a lot less as I've gotten older. So, pre-combustion techniques. Remove sulfur from fuel before burning. Yep, makes burning coal cleaner, but it also makes it much more expensive. So, end of pipe measures. Remove sulfur dioxide, nitrous oxides, using scrubbers or catalytic converters. So scrubbers are more for power plants. Catalytic converters are what you put on cars. So what it means is right before those pollutants enter the atmosphere out the exhaust pipe, you do something to collect them and reduce them. Photochemical smog, brown haze common in cities. Yep, we have it in Hartford. Formed when fossil fuel combustion products, nitric oxides, VOCs, react in sunlight, so more during the summer, creating a mix of ozone, nitric acid, aldehydes, PANs. So mainly nitric dioxide, and ozone, but contain over 100 pollutants with them. So don't worry, you're not getting tested on all of them. Caused by vehicle exhaust, industry, and sometimes forest fires as well. So not all of them are anthropogenic. Don't get me wrong, most of them are. When you start looking at it. But the formation of photochemical smog. Conditions you need for it are warm, sunny, traffic-heavy days. So think of Hartford rush hour traffic in the summer. Yep. Forest fires can also produce these, Indonesia and El Nino years. So also too, once again, Canadian forest fires. We also have our own in the United States. Don't get me wrong. Forest fires are occurring in a lot of areas, and even some that they shouldn't be. Reactions produce chemicals like VOCs, PANs, aldehydes, carbon monoxide, and ozone. VOCs oxidize nitric oxide into nitric dioxide, but do not destroy the ozone, leading to buildup near ground. So keep this in mind here. Where are we right here? VOCs oxidize nitric oxide into nitric dioxide, but do not destroy the ozone, leading to buildup near ground zero. So, so that nitric dioxide, so you start having that ozone really occur at the ground level. Smog peaks in the early afternoon, photochemical reactions. So why? Because that's when you've had the traffic occur in the morning. That's when you're at the warmest. That's when you got your sunlight. So, additional points. Smog causes strong oxidizing effects, damages health and materials. Low valleys with calm weather worsen smog. Yes, hills can trap pollution. I cannot stress this enough. Hills and mountains, really valleys. So what happens with a valley is this. The wind's going up high. Yeah, great. The mountains kind of block it. So When something smog rolls into a valley, it does not leave very easily, if at all. I was in the Chamonix Valley in Mont Blanc. You should be looking up out of the valley, like 9,000 vertical feet, and seeing beautiful mountains covered in snow. And like you couldn't see anything. It was just a gray zone because like even if you hiked up the valley and hiked up middle elevation, when you're looking out, you still saw nothing because of the smog. Like, and it's just because it rolled into the valley and nasty. Okay. Thermal inversion traps polluted warm air under a warmer air layer, preventing it from rising. So, what inversion is this? Like, you know how we're always taught that, like, oh, higher up on a mountain it's colder, right? And then like warmer down in the valley. Yeah, like higher elevations, you can be in the summertime and still have snow on the top of mountains. Really pretty cool, right? Yeah, that's true. But what happens with an inversion is the cold air sinks and then the warm air is up top. So it's like reverse. And the result is it really traps that air down in the valleys. It's like having your older brother or sister like trapping you and like falling on you and trapping you. All right. Winds can disperse smog. Winds are great for it. Rain removes pollutants as well, which is good. Like we just had rain here. It's end of July, and I'm so thankful because that'll help out. The breathing level at this time of the year. All right. Tropospheric ozone. Let's take a look at this. Ozone in the troposphere, or less than 10% of the atmospheric ozone, is harmful, not protective. So greater than 0.7 parts per million for 8+ hours is unhealthy. Acts as a greenhouse gas, 2,000 times stronger than carbon dioxide. Oh, yeah. So, keep this in mind about the ozone. Yeah, ozone is great, right? Like the ozone hole is bad. But ozone, this is something unfortunately has got to commit to memory. Ozone in the troposphere is harmful, not protective. So, yep, it basically traps heat. So, formation of this bad ozone, the tropospheric ozone, combustion of fossil fuels released by hydrocarbons and nitric oxides. Nitric oxide reacts with oxygen, forms nitric dioxide. In sunlight, that nitric dioxide breaks up, it splits back into nitric oxide plus oxygen. So you're like, wait a minute, it goes like this and then goes like that? Oh yeah, all right. The oxygen then combines with, another O2 molecule to form O3, which is ozone. So this continuous cycle creates ozone buildup at the ground level. Tropospheric ozone at the ground level is the bad ozone. It traps heat. So, impacts of tropospheric ozone. Tropospheric ozone is a major component of photochemical smog. It's a toxic gas and a powerful oxidant as well. So, impacts of biological elements of the environment. Irritation of the respiratory system, coughing, wheezing, sore throat, asthma, pulmonary disease, lung cancer. Reduced lung function due to constriction of muscles in the respiratory system, making breathing harder and limiting exercise. So again, irritation to the respiratory system and all the problems that go along with it. Increased susceptibility to respiratory infections or bronchitis, asthma, COPD, emphysema, stuff like that. If you have a precondition already with the lungs, this is really going to hit you hard. Eye irritation as well. Weakened immune system. Why? Because you can't get oxygen in. Your immune system is weaker. Inhibited plant growth. Just because the ozone, even small amounts, degrades chlorophyll and reduces and stops photosynthesis. Remember we talked about acid rain with leaves? Tropospheric ozone as well. So damage to plant cuticles, membranes, tobacco Ooh, issue with that because we grow quite a bit of tobacco here in Connecticut. It's the shade tobacco. It's the wrapping on the outer part of a cigar. Spinach and tomatoes as well. Necrosis on the upper surfaces of leaves. Necrosis is dead tissue. So, impact on materials. Damages to materials and reduces their aesthetic value. Let's bring that on down here. Okay. So let me put this on for a little bit longer. Work, we're going to go for until this evening. Yeah. All right. Damages materials and reduces their aesthetic value. It does. So, like, look, remember how we looked up those gargoyles by Notre Dame? Do you want to see nice, beautiful, well-sculpted gargoyles, or do you want to see ugly, melted wax rocks? You know? Reduces elasticity of rubber and fabrics. So, interesting enough, like, just went kayaking with a teacher at school, and we had some kayaks, and we were like using bungee cords for different things. Those are going to break down because of that over time. So, reduces lifetime of car tires. Yep, and bike tires as well. Rubber breaks down. Shortens lifespan of materials, bleaches fabrics, leads to higher cost of maintenance, upkeep, and replacement generally for materials. So, all right, let's talk shop a little bit on, just the Montreal Protocol and substances that deplete the ozone layer. 1987 is one of the most successful international agreements on a major environmental issue. Discuss the validity of this statement. Now remember, if it's asking you to discuss the validity, this probably is not a 1 mark or 2 mark question. This is, all right, they want you to show both sides. This isn't Disney where you're like, okay, that's Prince Charming and that's the bad guy. And they want a freaking conclusion as well. So, all right, Montreal Protocols. So, stuff you should definitely be talking about are ODSs, ozone depleting substances. If you don't mark those down, I don't know really what you're talking about. Talk about how ODSs are, what they're used in as well, and how they're used. Ozone, talk about what we talked about up top with the tropospheric ozone, about how it's formed, how its destruction, how it reforms, and then how it contributes to the ozone. Talk about the ozone hole, whether it is like growing, reducing, maintaining. All right. Talk about the legislation that was implemented with the Montreal Protocol in response. So, talk about how basically there's a black market for ozone depleting substances. Yeah, you got people going up and they're like, "Hey, that old refrigerator over there. You got some of that old refrigerant in that thing?" Yep, I got a little for you if you do. All right. Why? Because the people are cheap and they don't want, it's cheaper to buy stuff off the black market and just use it and what you have versus repairing and getting something new and nice that doesn't damage the ozone as much. So, yep. Talk about some of the alternatives to that we're now using, like HFCs. Talk about the good with them. Talk about the bad. Talk about how the Montreal Protocol was the first one that, like international agreement, we got people all together to work together globally, and how that led to other things like the Kyoto Agreement or the Paris Accords. So, talk about the successes. All right. Talk about the failures. Talk about international cooperation and speed and the extent of the ozone recovery and the impacts of the alternatives that we're using for refrigerants. So, and at the very end, mention a conclusion. So, talk about the good ways the Montreal Protocol is working, talk about the ways you don't think it's working, and then give a conclusion at the end. So, yep. All right. Next one, explain how urban air pollution could lead to significant losses. So, talk about a lot of the diseases we talked about, how like healthcare costs. A lot of these have to do with respiratory in the lung. Talk about like how you can have healthcare costs increase because of urban air pollution. All right. talk about how as healthcare costs go up and because people get sick, healthcare costs go up. Also, too, you're not, if you're sick from all this air pollution, you're not working. If you're not working, you're not producing. If you're not producing, you're not making the economy money. Talk about how you have early deaths and how that really affects the workforce. Like societies count on you to work generally from your late teenage years all the way up until your mid 60s. And if you die before you're in your mid 60s, that is a loss of resource. Think about how much has been invested into your education. And if you die early, they are losing years of your production for society. Yeah, bad way to kind of just a really cold-blooded way to look at it, but God's honest truth. Talk about the reduction in agricultural productivity. Talk about how this increases food prices. So supply and demand. If you now have 7 tomato plants instead of 10, that's going to jack up the prices. Damage to buildings and how it's costly to repair. If you have got a limestone if you got a skyscraper built out of limestone and it's getting hit with acid rain and you got to repair it, that's not cheap. So, yep. Just the increased cost of cleaning as well. From the effects of acid rain, costs, and also too, if you're going to put catalytic converters on all cars globally, they don't do that for free. That's going to increase the cost to reduce the air pollution. Just the cost of the end pipe technology. Same thing with like coal plants. We're making them a little bit better for the air. That means that the electricity is going to cost increase. And remember air quality, measuring it. People don't do it on a volunteer basis. People do it for money. So, the cost of having to maintain air quality. They have a huge air quality. I was talking with my wife about this. They've got 2 volcanoes right by Mexico City, and they are monitoring those like you would not believe. And so the cost of that has got to be pretty significant to the government of Mexico. So cost of educating people just about air quality as well. Think about how much effort went into educating people about COVID. Now you have to start doing that about air quality alerts, about how it might not be the best idea to go outside. And why, and look, people don't change very easily. Try to get a lazy smoker like my father to give up cigarettes or not smoke in a house, or just go out to the porch, and he just doesn't get it. All right. Cost of educating, so just also too, loss of revenue from tourism. People aren't going to go to a site if it's covered in smog. Think about that with London. Or is anyone going to London to see London smog? I know, don't think so. So because of that, you've got a loss of tourism dollars coming in. Property devaluation as well. People don't want to live in highly polluted areas. Imagine that. People actually want to live longer and better lives. If you're a company and you have to pay somebody to go work in a hazardous situation, that's called hazards pay. The cost to the company goes up. Also, the thing about this with asbestos, if you're paying someone to remove asbestos, there's a normal price tag for labor. Then to remove asbestos, you're paying them even more because they're basically shortening their lives. Alternative energy sources, converting to them might be expensive. So we can talk about that with air pollution, lead to economic cost and losses. So, all right, ending this on out. Last notes of your career with me. Reducing the impacts of tropospheric ozone. Alter human activity producing it. So that way we produce less. Regulate and reduce emissions at their source. End pipe emissions. Clean up and restore affected areas. The problem is that's reactive. That can get costly. Personal exposure reduction strategies. Stay indoors when the ozone levels are high. I've started doing this. I'm going to do it here in a little bit. Avoid sporting activities when the AQI is poor. So not worth it, okay? Use air filters indoors or wear respirators if going outside. I don't think like you're wearing a respirator outside. We've gotten to that level. But it's definitely one of those things you want to check into. My wife uses an indoor air quality filter, at her school and classroom because she's got an old school and it's not as good as the school we live in for air quality. So, avoid burning wood, candles, incense. Increases the particulate matter. Yeah, and just I will say that I don't burn candles anymore. Never really did burn incense. But off in Vermont, people do burn wood because it's free. If you have trees on your property, it's a free heating source. The problem is when you do burn wood inside, I will say you get like an ash layer inside no matter how clean you are, and like dust and stuff. So yeah, avoid smoking. Your generation's really good about that, especially in the United States. Europe, not as much. Still see quite a bit of you like sucking on a cigarette. All right. Yeah, and it really kind of destroys you can smell a cigarette a mile away, and just because of that particulate matter, it's also doing damage to your lungs if you're just around it secondhand smoke. For what it's worth, too, we used to, back in my day even, they're like, hey, how do you turn someone who's a 10 and bring them down to a 3? Put a cigarette in their mouth. So keep that in mind. All right, everybody. It's been great. Thanks for being with me through all these notes. And thanks for listening to me about the environment. I hope you do awesome. I hope you make this world a better place. So high five on the way out. All right. Where the heck's the stop sign?